Good morning, everyone. Let's continue. Number 12. This problem, we need to evaluate the expression in which there are two variables, x and y. So we need to evaluate this expression for x equals 3, y equals 2. So if we look at the expression has two variables, x and y. The value of this expression is not certain because x and y are variables, right? Yeah. Only when the values of x and y are given, we know the value for the expression. So how do we evaluate this expression for given values for the variables? As we seen yesterday, my process is firstly use parentheses to hold a place for the two variables. Firstly, I use parentheses to hold a place for variables, and then we put the values for variables in the parentheses. You can see this part, this parentheses was for x, so we put 3 in the parentheses, and these two parentheses was for y, so we put a 3, number 3, the value 3 in the two parentheses. Once we have the values plug in, then we can evaluate this expression. So no variables, all constants. Let's see. And we're gonna follow the order of operations. Order of operations is, please excuse my dear Aunt Sally, right? Yeah. So we can see we have power. We have a power exponentiation 2 to the power 3. What's cube of 2? Yeah, exactly. 2 cube is 2 times 2 times 2, which is 8. So we can replace that part with 8. The first part, numerator is 11 times 3, which is 33. Denominator is 2. Yeah, if you go ahead to convert 33 over 2 as decimal, you will have 16.5. But what if when you look at the problem, the answer is a fraction, then you would have to write the answer as a fraction. So how do you add the two fractions together? We covered how do we process fractions, right? Yeah. Put a 1, yeah, 8 over 1, that's a good idea. We can rewrite 8 as 8 over 1. We are going to add up the two fractions. Do the two fractions have the same denominators? No. So what do we need to look for in order to add them up? Least common denominator, exactly. Least common denominator of the two fractions is least common multiple of the two denominators. What's least common multiple of 2 and 1? 2, exactly. So the first fraction, 33 over 2, has a denominator 2 already. The second fraction, 8 over 1, we need to rewrite that fraction as its equivalent fraction with denominator 2, right? So how do we go from 1 to 2? Times 2. Remember, we can't just do it on the bottom. We have to do the same thing to the top in order to keep the fraction unchanged. So now we have 33 over 2. 8 over 1 right now is 16 over 2, right? Yeah, the two fractions have the same denominators now. Remember the rule. When we add or subtract fractions with the same denominator, do you remember the rule? Keep the bottom, yeah, solve the top, reduce the result. So we keep the bottom, solve the top, 33 plus 16. What is 33 plus 16? 49, right? Yeah. So if you look at answer choices are fractions, then 49 over 2 would be the answer. Let me see. or 12. You see that? Yeah. So if you ask, do I need to write the answer as decimal or fraction? It really depends on the answer choices, right? Yeah, depends on answer choices. My problem, if you took my class before, no, you never, none of you have taken it. My exams are all multiple choice questions. All multiple choice questions. So really depend on the answer choices. Yeah, let's make a summary. How do we evaluate expressions for the given values of the variables? So step one, use parentheses to frame, to hold a place for the variables first. And you need to remember which parentheses represent which variable. Second step, plug in the values for the variable. Yeah, put the values in the parentheses. Step three, evaluate or operate the expression. So this one is yours, okay? The expression that is given is 2x minus 9 all over 5x. You're gonna find the value of this expression for x equals 4. That's the first step. That's the first part of the problem. And then you're gonna evaluate the same expression for x equals 18. For x equals 18. I'll give you a couple minutes. This problem I'll say is easier because it only has one variable. Bless you. 2x minus 9 all over 5x. The first part, x equals 4. The second part, x equals 18. I have 3 steps, right? Parentheses, hold the place first, plug in the value after, and then operate. Yeah. This problem is very straightforward because the expression only has one variable. I see most of you have the correct answer. Let's see the first part. X equals 4. I see you guys just plug in, use the calculator, right? For the first test, you won't have a calculator. So when you practice for the first chapter test, try not to use the calculator. Try to see if you can manually get the value. Two x. So look at my I would use parentheses to frame the to hold the place for variable x first, and then put the 4 value 4 in the parentheses, and then evaluate. Yeah, numerator multiplication before subtraction. 2 times 4 is 8. 8 minus 9. Denominator 5 times 4 20. Numerator 8 minus 9 negative 1. So the answer is negative 1 over 20. I see most of you have the correct answer. Second part. for different value of x. We're going to do the same thing. Use parentheses to hold a place for a variable, and then put the value of the variable in the parentheses, and then we evaluate. Yeah. Suppose you pretend you are taking a test. You don't have a calculator, right? To see if you can get the value without a calculator. What is twice of 18? 36 minus 9 denominator. What is 5 times 18? 90. Yeah. Numerator, what's 36 minus 9? 27 over 90. Could we reduce this fraction? Yeah. 27, 90. What's the GCF? 9, exactly. Yeah. So we divide the numerator by 9. Divide the denominator by 9. Numerator becomes 3. Denominator becomes 10. Right? So that's the answer. Very good. Those two problems, one example, one practice, is about evaluate expressions for given value. Next up, a very simple concept. Differentiate between equation and expression. So we have two concepts here: equation, expression. Yeah, very easy concept. Equation, if you see an expression with equal sign in it, if you see something with equal sign in it, then that is an equation, of course. If you don't see the equal sign, then that's an expression. Super easy. Number 13. Let's look at number 13. Look at the thing. Do you see an equation? Do you see an equation or expression? Do you see equal sign in it or not? Yes. So 13 is an equation or expression? Is 13 equation or expression? Of course, equation. Yeah, I don't worry about this is very straightforward problem. Number 14. Look at what you are given. Is that expression or equation? Expression, yeah, without the equal sign, right? Yeah, so those are super simple. All right, so now let's move to next part. Operations with decimals. Yeah, we have learned the number system. We know the real number set include rational numbers and irrational numbers. And both rational numbers and irrational numbers can be defined as decimals, right? Rational numbers are terminating decimals and non-terminating by repeating decimals. Irrational numbers are non-terminating, non-repeating decimals. So basically, real numbers are decimals. Okay, yeah, we can just see real numbers as like all the decimals. So we want to see how do we operate the decimals? How do we plus, minus, multiply, divide with decimals? So firstly, let's look at a decimal. 23.45. 23.45. Let's pretend this number, this decimal represents dollar, represent money. Like you buy something, you pay $23.45, right? Yeah. So the decimal point, the red dot, is called the decimal point or decimal separator. Decimal separator. On the left, to the left of the separator, we have the integer part. So to the left of the decimal point, that is the integer part. Or sometimes we call integral part. Integral part. $23, right? 23 is an integer, whole number. And the part to the right of the decimal point, that is the fractional part. Because it's not enough for 1. It's not enough to be an integer. So that is the fractional part. So all those digits, they have place value. So let me explain what is place value for decimal. Let's look at the place right next to the separator, to the right of the separator, but next to the separator. That place value is tenth. So this is 10. Let me write it down. It's a 10. Yeah, tenth. Yeah, or when it comes to money, then that place value dime, right? Yeah, so 4. You have a 4 in that position. That means you have 4 dimes there, right? Yeah. So now let's look at the orange part. That place value is a hundredth or cent. In money is a cent, the place value. So you have a 5, you have number 5 at that place. That means you have 5 cents. And the digit, the place to the left of the separator, where the 3 is, that is the ones. That is the ones. So the blue part, that's the ones. O-N-C-E, ones. Okay. You have a 3 there, means you have $3. And let's see the purple place. The purple place is a tenth. So this tenth. And the value place, the place value of that place is tenth, or how do you say that? How many $10, right? So you have 2 there, means you have 2 $10. That is $20. Does that make any sense? So we have, for decimals, we have a place values. We have place values. Now, how do we understand this number? How do we understand this decimal from the point of view of fraction? So as we know, the place value of 2 is 10. So we have 2 times 10 here. The place value for 3, the blue part, is ones. So we have 3 times 1 here. To the right of the separator, in the green place, we have a 4. Place value is 1/10. So we have a 4 times 1/10. So 4 dimes. In the orange place value is 100th. We have 5 there, so we have 5 times 1/100. So that's how do we represent a decimal in terms of fractions, as fraction. So we can keep going to evaluate this fraction. So this is 20, this is 3, this is 4/10, this is 5/100, right? And then you find the least common multiple of the denominators. Yeah, what's the least common multiple of those denominators? What's the least common multiple of the denominators? You can see this as 20/1. This is 3/1, right? And you have 4/10, 5/100. What's the least common multiple of 10 and 100? 100. Least common multiple is 100. Yeah. So you can multiply both top and bottom by 100, by 100. It's the same. This you're gonna multiply by 10, right? And then we would have in the numerator 20 times 100 is 2000. 3 times 100, 300. 4 times 10, 40. 10 times 10, 100. And then 5/100. When they have the same denominators, we keep the bottom, solve the top. 2000 plus 300 plus 40 plus 5. And that gives us, yeah, try the numerator and tell me what's the sum in the numerator. 2000 plus 300 plus 40 plus 5. That actually is 2345, right? Correct? Yeah, over 100. Yeah. Yeah, there's a reason I want to show you this. You can see the original decimal is 23.45, right? You can see 23.45, 23.45. If we remove the separator, we would have an integer or a whole number, 2345, right? See that? And since we have 2 digits to the right of the separator, so we divide by 100. You see what I'm talking about? So when you have a decimal, how do you write a decimal as a fraction? You just remove the separator, and you will have an integer, right? You put the integer in the numerator. And what about the denominator? And look at how many digits to the right of the decimal point. Like we have 2 digits, right? So you divide by 100, 2 zeros, 100. Does that make any sense? Yeah, there are many rules about the decimals. And the other way around, if you divide 2345 by 100, you will have 23.45. So if you have a number, you divide by 100, which is equivalent to move the decimal point to the left 2 times. Does that ring a bell? Divide a number by 100 is equivalent to move the decimal point to the left twice. So 2345 is a whole number. If we write a number as a decimal, we would have 2345.00, right? Yeah. So divide this number by 100 is equivalent to move the decimal point to the left twice. And we would have 23.45. Better? We are talking about the operations with decimals. So let's see how do we add decimals. I have 2 examples here. Number 1 is addition. Number 2 is subtraction. So let's look at addition first. The example is 9.087 plus 15.31. We are adding the 2 decimals. Adding 2 decimals is very easy. Addition of decimals is very easy. Let me show you how do we add the 2 decimals. We are going to process the addition vertically. We are going to write the 2 decimals like this. One on the top, the other on the bottom. Yeah, we line up the 2 decimals. We align the 2 decimals, make sure the separator are aligned. When the separator are aligned, all the places are aligned, right? Yeah, so you can see this is ones, this is tenths, this is tenth, and that is hundredths, right? And then thousandths. Yeah, so when we add the 2 decimals, we want to align the 2 decimals vertically and make sure the separators are aligned. Now we can add them up. Now we can add them up. We're gonna go from right to the left. We're gonna go from right to the left, this direction. Okay? Yeah. 7, when you don't see here, you can put a 0 to hold the place. Yeah, to the right of the separator in a decimal, you can add zeros in the end, as many zeros as you want. It won't change the value of the decimal. So make sure it's in the end of the decimal on the right, to the right of the decimal point. So we have 7 plus 0. So for this place, we have 7 plus 0, that is 7, right? Yeah. And then we see the hundredth. 9 plus 1 is, sorry, 8 plus 1 is 9. And then we have a tenth. 0 plus 3, that's 3, right? And then we're gonna bring down the decimal point. And we have ones. 9 plus 5, what do we have? 14, yeah, exactly. So you cannot write 14 right here, right? So you have to give, you're gonna give the tens one digit, right? Yeah, because the 9 plus 5 is 14. So for the ones, you have a 4. You have another 10, and you give the 10 to the tens. So now you have 2 tens. So you have 20 here. Does that make sense? Does that make sense? Let's say that is blue. So 24.397. Yeah, how do we add up the decimals? Make sure we go from the right to the left. Align them vertically. And then we go from the right to the left. So you practice this one. Try to practice this one. 0.0085 plus 1.799. You have 1 minute. Line them up. Very important. 0.0085 plus 1.799. Yeah. Make sure the decimal separator are aligned. Let me know what you have. What's the answer? And not use calculator, okay? This will, yeah, check. That's good. Yeah. So what do you have? 1.80. What's the next? 75. Exactly. Very good. So let me show you how do we get that answer. Remember, we go from the right to the left, right? Yeah. So 5 first. 5 plus 0 is 5. 8 plus 9 is 17. So we have, well, we're gonna give the previous place 1 digit, right? And 9 plus 1, we have 10. So we have another 1 to the 10th. 7 plus 1 is 8, and we bring down decimal point. 0 plus 1 is 1. Very good. So are we okay with the addition of decimals? Subtraction. Subtraction is a little bit more complicated. Let's look at this example. So we have 5.73 minus 0.0821. When it comes to the subtraction, we need to make sure put a number in front of the subtraction symbol on the top. Put a number behind the subtraction on the bottom. So don't mess with the order. Yeah. So 0.0821. Also make sure the decimal places are aligned. The separator are aligned. Separator is here. Is here. Okay, I'm gonna do. Remember, you see nothing here, right? Yeah. Remember, for a decimal, you can add zeros to the end of to the right of the decimal point. All right, let's see how do we subtract. Look at this column. So tens, hundreds, thousands, that is 10,000s, right? The purple place, yeah. And we want to use 0 to minus 1. But the zero cannot minus 1, right? We would have negative number. So in order to minus 1, we have to borrow. We have to borrow from the thousands. So here we're gonna borrow 1 from. Let me use this color. We want to borrow 1 from the thousands, the orange column, right? Yeah. So we're gonna borrow 1 from the orange column. So 0 here become 10. And here, because you borrow 1, so here becomes what? 9. Yeah. Become 9. Do you actually 3 becomes 2 though? Because you have 30 here, right? You have 30. But you borrow 1 from 30, so you have 29 here. Do you see what I'm talking about? So you borrow 1 from 30, you have 29. Yeah, for those hundreds and thousands place. Okay, let's see. So now we have 10 minus 1, we have a 9. And in the orange column, 9 minus 2, we have 7, right? Let's color this as green. For the green column, 2 minus 8, not big enough. So we have to borrow again. So we're going to borrow 1 from the 10th. So 2 becomes 12. 2 becomes 12. The 7 becomes 6, right? Yeah. So 12 now is enough to minus 8. So we have a 4. And let's see this column. Let's make that yellow. 6 minus 7. 6 okay, sorry, my bad. Yeah, 7 becomes 6 now. 6 minus 0. 6, yeah. And then we bring down the decimal point. For the ones, 5 is 5. 5 minus 0 is 4. 5, I'm sorry. 5 minus 0 is 5, of course. All right, this is a very good problem. We kind of like a borrow, we have to borrow like twice. You borrow 1 from 30, you have 30 becomes 29, right? And 0 becomes 10 here. And when you try to use 2 to minus 8, you have to borrow again. So 2 becomes 12, 7 becomes 6. And make sure all the numbers on the top has to be bigger than the number on the bottom. So the difference, the subtraction is 5.6479. Your turn. Your turn. See if you can do 2 point. $2.64 minus 0.0486. 2.64 minus 0.0486. Firstly, line them up vertically. You want to put a 0. You want to use a 0 to hold the places. Let's see how do we process this. Anyone has the answer already? What is it? 2.5914. Yeah, that's correct. So let's see the purple part. The purple column, 0 has to borrow 1, so it becomes 10, right? It becomes 10, and 40 will become 39. So 10 minus 6, we have 4. 9 minus 8, we have 1. 3 minus 4, not enough, so we have to borrow. We have 3 becomes 13, and 6 becomes 5. 13 minus 4, we have 9, right? For the green column. 5 minus 0, we have 5 for the yellow column. Blue, 2 minus 0 is 2, and we bring down the decimal point. Same with yours, 2.5914. Very good. That's subtraction of decimals. Now let's see multiplication. Let's see multiplication. So let's look at this example. 2.91 times 3.2. Multiply the two decimals. 2.91. 2.91 times 3.2. Okay, there are different methods, okay? Yeah, the first method is, this is how you're gonna do. Firstly, you still have to vertically line up the two decimals. But when you line up vertically for the purpose of multiplication, the way you want to line them up is you want to make sure the last non-zero digits are aligned. Yeah. Now the decimal point, you can see the decimal point is not aligned. They are not aligned. We are not adding or subtraction or minusing. When we add or subtract, when the decimal point are aligned, right? But we are multiplying. So when we multiply, we make sure the last non-zero digit in the two decimals are aligned. So the last non-zero digit of 2.91 is 1. The last non-zero digit of 3.2 is 2, right? Make sure they are aligned. Am I clear about that? Yeah. So and then you're gonna ignore the decimal points. And then you're gonna ignore the decimal point. You're gonna multiply 291 by 332 as usual, as whatever the whole number. So I assume we know how to multiply two numbers, okay? 291 times 32. So 2 times 1 is 2. 2 times 9 is 18. 2 times 2 is 4. We have a 5, A2 here, right? And then 30 times 1 is 30. And then 3 times 9 is 27. So we have 873 here. 8,730 here. And then we add them up. 2, this is 9312, right? 9312, yeah. So line them up, and then ignore the decimal point. You will have a whole number. You're gonna write a whole number this way. 9,312. Now you're gonna place the decimal point. So first again. Yeah, now you're gonna place the decimal point. How do we place the decimal point? Look at the first decimal. Look at the first decimal, and tell me how many non-zero digits to the right of the separator. How many? 2, right? Yeah, we have 2 non-zero digits to the right of the separator. For the second decimal, 3.2, how many non-zero digits do we have to the right of the separator? 1, right? Yeah, yeah. And what is 2 plus 1? What is 2 plus 1? 3. So we are going to place the decimal point this way. 1, 2, 3. We're gonna place decimal point right here. Okay? Yeah, we get a whole number. We get a whole number. The whole number 9,312 actually is 9,312.0, right? Yeah. And then we're gonna move the decimal point to the left 1, 2, 3, 3 times. We got a 9.312. That's the answer. A very useful way to know where do we place the decimal point is this. We're gonna estimate, okay? Yeah, 2.91. Is 2.91 very close to 3? Yeah, okay. So how about we use 3 to approximate 2.91? So 2.91 is close to 3, right? Yeah. 3.2, the second decimal, 3.2. Is 3.2 also very close to 3? Yeah, so 3 times 3 is 9, right? So the multiplication we're looking for should be pretty close to 9 as well. Yeah. So you would know, okay, I should place the decimal point between 9 and 3. The answer is 9.312. Otherwise, if you put the decimal point between 3 and 1, you get 93.12. That is too big, right? You know what I'm saying? Because the first factor is close to 3. The second factor is close to 3. 3 times 3 is 9. The answer, the product is supposed to be close to 9, right? Not the 91, but too large. Yeah, or 0.9 is too small. Do you see what I'm talking about here? Am I clear about my point? Yeah, so there's multiple ways to know where do you place the decimal point. Let's make a summary here. How do we multiply two decimals? Line them up vertically. But when we line up the two decimals for the purpose of multiplication, we do not line up their decimal points. Instead, we line up their last non-zero digits. That's the first thing. Yeah. Second thing we do is to ignore the decimal point and multiply the two numbers as usual. In our case, after we multiply 291 by 32, we got a 9,312. That's the second thing. The third thing, we're gonna place the decimal point, right? So there are different ways to know where do we put the decimal separator. One easy way is you look at the first factor. 2.91 has 2 non-zero digits to the right of the separator. Second factor, 3.2, has 1 digit to the right of the separator. 2 plus 1 is 3. So you're gonna move the decimal point in 9,312 to the left 3 times to get the answer. All right. Also, we can't spend too much time on those simple things. Another way I want to explain this problem. Do you remember earlier? 2.91 times 3.2. Do you remember earlier when we have a decimal? How do we write a decimal as a fraction? So look at the first factor, 2.91. 2.91 actually is 291 over 100. Do you agree that? Did we do similar thing in the beginning of this section? I said we have the decimal 2.91, right? If you remove the separator, you will have a whole number. In this case, if we remove the decimal separator, we would have 291, right? Right? Yeah. Since we have two non-zero digits to the right of the decimal point, we can divide 291 by 100. Two zeros behind one. Did we do similar thing earlier? Yeah. And the second fraction, 3.2. Yeah. If we remove the separator, 3.2 will become 32, a whole number, 32, right? So that's the numerator. Because 3.2 has one non-zero digit to the right of the separator, we're gonna have a 10 on the bottom. Yeah, you can play with it. You can reverse it. 291 divided by 100, you move the decimal point to the left twice, you have 2.91, right? 32 divided by 10, you move the decimal point to the left one time, so 3.2, right? You can reverse it, double check. So we wrote both decimals as a fraction now. Yeah, let's see, how do we multiply fractions? Yeah, we learned how do we multiply fractions, but here, do not apply my rules, okay? We do not vertical, diagonal. In this case, we are going to just multiply cross, okay? We are going to just multiply cross. 291 times 32, we did that already here. We get 9,312. Denominator, 100 times 10. What is 100 times 10? 1,000, right? Yeah. Remember we seen earlier, we divide a number by 1,000 is equivalent to move the decimal point to the left 3 times. So 9,312 would become 9.312. Yeah, another way to process multiplication of decimals. You convert both factors as a fraction, and then you multiply the fractions, and then you go back, convert the fraction as is equivalent decimals. Your turn. You guys practice. Let's see. 9 times 0.6. Practice. 9 times 0.6. Okay. I think the important thing is we make sense of the numbers. We are multiplying 9 by 0.6, right? Yeah. Is 0.6 pretty close to 0.5? Huh? Is 0.6 very close to 0.5? Yeah. Is 0.5 half? Yeah, 0.5 is half, right? Yeah. So if you multiply a number by half, means you get half of the number, right? What's half of 9? Half of 10 is 5, right? If you have a $9, what's half of $9? $4.50, right? $4.50. Yeah. So the answer is supposed to close to, not exactly, of course, would it be close to 4.5? Yeah. So let's see what you have. Let me know. 5.4. Awesome. Exactly. 5.4. Exactly. Yeah. So one way you can process like this: 9 times 0.6. 0.6 is 6 over 10, right? Exactly. right? 0.6 is 6 over 10. And you can write 9 as 9 over 1. And you multiply across, 9 times 6 is 54. 1 times 10 is 10. When you divide a number by 10, is equivalent to move the decimal point to the left once. Okay? Yeah. Does that make sense? Yeah, so we actually have a very important rule here. When you have a decimal, when you multiply the decimal by 10, 10 is 10 to the power of first, right? When you multiply a decimal by 10, it's equivalent to move the decimal point to the right one time. I want you to remember the rule. Maybe you already know it. And number two, if you multiply a decimal by 100, 100 is 10 to the power of 2, right? 10 squared. The exponent is 2. It's equivalent to move the decimal point to the right twice. When you multiply a decimal by 1,000, we have 3 zeros in 1,000, right? Then that's equivalent to move the decimal point to the right 3 times. You can generalize this pattern. If you multiply a decimal by 10,000, then you move the decimal point to the right 4 times, right? If you multiply by 100,000, you move the decimal point to the right 5 times, and so on and so on, right? So that's how we multiply a decimal by power of 10. The power is a positive. What if you need to divide a decimal? 1, 2, 3, 4. What if you have a number? You need to divide the number by 10, by 100, by 1,000, by 10,000. Yeah, divide a number by power of 10. Then you're gonna move the decimal point to the left a certain times. When you divide it by 10, you move the decimal point to the left 1 time. So you have 1, 2, 3.4. When you divide a number by 100, you move the decimal point to the left twice. You have 12.34. If you divide the number by 1,000, since we have 3 zeros in 1,000, you move the decimal point to the left 3 times. You have 1.235. All right? Does that make sense? Yeah, that is a multiply. Let's multiply. Division. Division. Let's take this problem as example. I'm going to show you how do we divide decimals. How do we divide the decimals? We are going to use long division to divide the decimals. The process of long division is long. That's the reason it's called a long division. But when we use a long division, we have to make sure the divisor is the whole number. Yeah. So in this expression, this number, the number in front of the division symbol is called a dividend. We talked about this before, right? The number to the right of the division symbol, that's called a divisor. Yeah, we use a decimal to divide by another decimal. The first decimal is a dividend. And the second decimal is a divisor. We do need to remember the names of the 2 decimals, of the 2 numbers. Okay, as I said, when we apply long division to divide the decimals, we have to make sure the divisor is a whole number. Look at the divisor right now. The divisor is a 0.25. Of course, it's not a whole number, right? Yeah, okay, so how do we do that? This is how do we do that first. Could we write 6.3 divided by 0.25 as the quotient of 6.3 and 0.25? We did it the other way around before. We know the fraction bar is a division symbol, right? Now we convert the division symbol as a fraction bar, would be the same, right? Okay. Technically, that's not a fraction because the decimal is not integers, right? Yeah. But the rules, the multiplication rule, multiplication property and the division property still hold, still true here. So I'm going to multiply both top and the bottom by 100. Yeah, I wrote the original division of the two decimals as a quotient of the two decimals. The numerator is the dividend. The denominator is the divisor. Yeah, the divisor is 0.25, but I want the divisor be a whole number. Yeah, how do I, make the divisor to be a whole number? If I remove the separator here in 0 to 25, do we have a 0 to 5? Then that actually is 25, right? Yeah. So in order to do that, I multiply by 100 because there are two non-zero digits to the right of the decimal point, right? So we multiply by 100. We know if we multiply a number by 100, it's equivalent to move the decimal point to the right twice, then we would have 25. Yeah. So after we multiply the denominator by 100, the denominator becomes 25. Same with the numerator. You see, when I multiply the denominator by 100, we do this. I did the same thing to the numerator, right? Yeah, without changing the value. 6.3 times 100, same with earlier. You multiply a number by 100 is equivalent to move the decimal point to the right twice. Tell me, you move the decimal point in 6.3 to the right twice, what do you have? Say 630, right? You see that? Yeah, that's how do you change the divisor in the division as a whole number. Am I what? Not always. For example, if you have 7.2 divided by 0.3, you multiply by 10, right? And the purpose is to change the denominator, the divisor as a whole number. The smallest whole number. For this case, 0.3, you don't want to multiply 100. If you multiply 100, you have 30.
Like the one on top right now, if that was the denominator, it'd be by 10, right? So it goes by the denominator.
Yeah, depends on the denominator. Because when we do the long division, we need a divisor be a whole number. Yeah. Yeah, before we process the division by using the long division, we want a divisor become a whole number. We want a divisor as a whole number. How do you say that? We want a divisor be a whole number. But you don't want a very large whole number, right? For example, here, 0.3 times 10. That would be enough to get a whole number, which is 3, right? If you want to multiply 100, you will get a 30. Then both numerator and denominator will become very large number. That's not convenient. So you want to just count the number of digits to the right of the decimal point. Here you have one digit only, right? So you only need to multiply 10 to get a whole number. Here we multiply 100 is because 0.25 have two non-zero digits to the right of the decimal point. That's why we multiply 100. Of course, if you really want to multiply by 1,000, 10,000, it will work. It's just that you give yourself trouble. Yeah, you want the smallest, right? Smallest whole number. Is that clear? Yeah. So now when we have the denominator or the divisor as a whole number, we are ready to process the long division. Okay, let me show you how do we process the long division. So original expression now becomes 630 divided by 25, right? Yeah. The dividend The dividend right now is 630. The divisor right now is 25. It's a whole number. That's what we want, right? Okay, let's see the long division. Let's see the long division. Divisor is 25. Could the 25 go into 6? It's too small, right? Yeah. Then we want to look at the 36. The first two digits, 36. Could the 25 go into 36? I mean, at least one time, actually twice, right? Twice. Could the 25 go into 63? Sorry, did I say it wrong? My bad. Yeah. Could the 25 go into 63? Twice, actually, right? Because twice of 25 is 50. 50 is still smaller than 63, but 3 times is not. It doesn't work because triple of 25 is 75. 75 would be bigger than 63, right? So 25 could only go into 63 twice. Of course, with the remainder. We'll see what's the remainder. As we see, 25 goes into 63, not 36, 63 twice. So we're gonna write 2 here. Yes? Yeah, yeah, we wanna know how many times 25 go into 63. Of course, we know 25 will not go into 63 completely, right? Because it's not a factor of 63, but because it's smaller, so we want to know how many times it could with the remainder. So now we know 25 goes into 63 twice, right? So we can write 50 right below 63. What's the remainder? What's the remainder? 13, yeah. So let's pause here. Let me explain that again. Yeah. We're gonna look at how many times 25 go into 6. It's not possible because 25 is bigger than 6. So we look at 63. How many times 25 go into 63? 2 times, right? 3 is not enough. Yeah. 75 is bigger. So twice only with the remainder 13. Okay? Remainder 13. Yeah. And let's see how many times 25 go into 13? Could a 25 go into 13? No, it's bigger than 13, right? So now we're gonna bring down the next digit. We're gonna bring down the 0. We're gonna have 130. Okay? We're gonna repeat it. Yeah. Let's see how many times 25 go into 130. Yeah, 4 times, 25 is a quarter, right? A quarter of 100. So 4 times we have 100. 4 times we have 100. We will have a 30 remainder, but 30 is still bigger than 25. So 25 can go into 135 times. With the remainder, what? 5, yeah. So if you multiply 5 by 25, you have 125 with the remainder 5, right? All right. We're not done yet. Yeah. We are dividing completely. So we will have a decimal as the quotient. And now let's see how many times 25 going to 5? No. Right? So we're gonna bring down another digit, but we don't have any digit no more. So this is how do we do it? 630 is a 630.00. You can add as many 0 as you need, right? It's like a $620. If you print out the receipt, you will have 630.00, right? The same idea. Whole number actually is a decimal. Yeah. So now you have a 0 to bring it down, right? You can bring down 0. You can bring down this 0. This 0. You can bring it down. And you would have 50 here. You will have 50 here. All right, 25. Could the 25 go into 50? Good, yeah, good news. 25 actually go into 50 completely twice. So we have a 2 here. We're gonna put a 2 here. 2 times 25 is 50. Remainder is 0, right? Yeah. So when we have the remainder 0, that means our long division is complete. We cannot go further. Yeah, means we divide 630 by 25 completely now because the remainder is 0. And now let's see what's the quotient. Yeah, we are looking for the quotient of 630 and 25, right? Where is the quotient? You're gonna find the quotient on the top of the division symbol, 252. But the answer is not a 252. The answer is 25.2. You have to place the decimal point between 5 and 2. Yeah, because everything in a long division is very neat. In a long division, all the places are aligned vertically. Yeah, this is a decimal point. This is a tenth. This is a ones, hundreds, the ones, tenths, hundreds. Yeah. So all the places are aligned. So the answer, the quotient is 25.2. That's how do we apply long division to divide decimals. How about let's make a summary? Yeah. When we divide decimals, there's a method in the long division. And when we use the long division to divide decimals, we want the divisor to be a whole number, right? We want the divisor to be a whole number. How do we change the divisor to be a whole number? An easier way, actually, another easier way is if we move the decimal point in the divisor to the right twice, we would have 25 as a whole number, right? We just need to do the same thing to the dividend. We move the decimal point in the dividend to the right twice. We got a 630. Yeah, that might be easier, right? Might be easier to randomize the quotient and multiply 100. It's the same thing, actually. The same thing. Yeah, in other words, whatever you do to the dividend, you can do the same thing to the divisor. Yeah, whatever you do to the divisor, you're going to do the same thing with the dividend. You move the decimal point in the divisor to the right twice. You're going to do the same thing to the dividend. So the dividend becomes 630. Divisor becomes 25. So once you have the divisor a whole number, become a whole number, you're going to use the long division. You're going to divide the numerator, the dividend by the divisor completely. Completely means that eventually you need to get a 0, right? Yeah. So probably you will have a decimal as a quotient. So make sure you know to place the decimal point between 5 and 2. You're going to line up those decimal points. Make sense? You want to try one yourself? You try 22 practice. You try 2.211 divided by 6.7. Yeah. 2.211 divided by 6.7. Huh? Yeah. Restroom? I know there's one in the second floor. I never look for one in the third floor. I know there's one in the second floor. Yeah, let's see, how do we divide 2.211 by 6.7? Yeah, earlier, what did we do in the example? We want to change the divisor as a whole number, right? How do we do that? How do we do that? To the right, how many times? 1 times, yeah. We're going to do the same thing to the dividend, right? Yeah, so you're going to move this to the right 1 time. So the division actually becomes 22.11 by 67, right? Yeah. And then you're going to do the long division. I'll give you a couple minutes and you work on that first. long division, you're gonna put dividend under the division symbol, divisor to the left of the division symbol. Yeah, we can see 67. Could the 67 go into 2? Of course not. Could the 67 go into 22? Still not. So we're gonna consider 221, right? Yeah, how many times is 67 going to 221? How many times? You can try. What, I think at least twice, right? Actually, try 3 times. Yeah, let's try 3 times. Yeah. Multiply 67 by 3. 201. Yeah, that means 3 works, right? Yeah, it could go into 221 3 times. What's the remainder? 20 is the remainder, right? Subtract 201 from 221, you have 20. Yeah, that's the remainder. Could the 67 go into 20? No, of course not, right? So you have to bring down the next digit, which is 201. And you know already 67 going to 201 3 times, right? And you have a remainder 0. Yeah, what's the quotient, by the way? 33 is the quotient? No, what is the quotient? Where do you place the decimal point? Yeah, in front of 3, exactly. You have a 0.33. Yeah, the quotient is 0.33, okay? The quotient is 0.33. Yeah, that basically is everything about decimals. We explained the value, the place value in a decimal, right? And we covered addition, subtraction, multiplication, and division. Yeah. We have 5 more minutes. Let's see. The next section would be the last section though. Properties of real numbers. 1.6. Properties of real numbers. So maybe you can use the 5 minutes to copy down those formulas. Yeah, let's see the formulas. The first property, commutative properties. Yeah, commutative properties. For real numbers, both addition and multiplication satisfy commutative property. Yeah. Means what? Means if we have 2 plus 3, we have 2 plus 3, right? If we interchange 2 and 3, we would have 3 plus 2. Then the results would be still 5. It will not change the value. Yeah. So that is the commutative property for addition. Yeah. For any two given real numbers, a plus b equals b plus a. It doesn't matter which number in front, which number is after, right? Yeah. Same with multiplication. Same with multiplication. It's like if we have 2 and 3. If we multiply 2 by 3, we got a 6. If we interchange the two values, 3 and 2, we get a 3 times 2. Do we still have 6? Same thing, right? Yeah, so for any given real numbers, a times b is the same with b times a. So you can interchange the values in the addition or multiplication. It will change the value of the result. The important thing I want to point out is commutative property only applies for addition and multiplication. It doesn't work. Commutative property will not work for subtraction and division. Yeah, let me show you why. Let's take 7 and 4. Yeah, let's look at this subtraction. What is 7 minus 4? Of course, 3, right? But could we interchange the two values in the subtraction? Like I put I put 4 first. I use 4 minus 7. What is 4 minus 7? What is 4 minus 7? Yeah, -3. Yeah. They are not equal anymore, right? They are not the same. They are not the same. What are they? They are what? We learned this concept. 393 is what? 393 is what? Opposites. Okay, yeah. As a conclusion, you probably want to write it down. Yeah. 7 minus 4, 4 minus 7, they are opposites. The pattern is always true. Means what? Means A minus B, A minus B, and B minus A are opposites. Okay, they are not the same. They are opposites. You see what I'm talking about? You want to write it down? Yeah, please write it down. A minus B and B minus A are opposites. Are opposites. A minus B and B minus A, they are not the same. So it means the subtraction of real numbers do not satisfy commutative property, but they are opposites. They do closely related. Okay, all right. Commutative property doesn't work for division either. Yeah, let me show you. Let me show you. Let's say we have 10 divided by 5. Dividend is 10 divided 5. What's the quotient? Of course, 2. Yeah, of course, 2. What if I interchange the dividend and the divisor? What is 5 divided by 10? 5 divided by 10 is 5 over 10. Yeah, if we know how do we convert the fraction bar to division, then the opposite would be still true. How do we convert the division as a quotient? Dividend on the top, divisor on the bottom. What is the 5 over 10? What is 5 over 10? Huh? Yeah, $5 out of $10 is half, right? Okay. Of course, they are different, right? Then what's the connection between them? 2.5. What's the connection between them? Reciprocals. Reciprocals. Okay? 2 is 2 over 1. Yeah, 2 over 1. You flip it. You have a 1 over 2, right? Yeah, so here you want to write down this sentence. A over B and B over A. Of course, they are not 0. Yeah, of course, the bottom cannot be 0. Are reciprocals. They are not the same. So we know the commutative property does not work. But they are also closely related. A over B, B over A, they are reciprocals. All right, guys, we'll continue tomorrow.